So the purpose of this lab is to determine the molar mass of butane by collecting the gas over water. Students will then compare the experimentally determined molar mass with the accepted molar mass of butane and determine how specific errors could have resulted in the deviations they observed. So I'm going to go through this procedure. You've already learned how to do these types of problems. Now you're going to actually see me do it in the lab, so when you get into the lab, it's totally seamless. Okay? So for number 1, you're going to immerse the lighter in the large beaker of water, and you're going to remove it. You're going to dry the lighter thoroughly with a paper towel. You're going to weigh the lighter, and then you're going to record the mass in the data table.
So I'm going to take the lighter, and I need to submerge it in water, just to have it totally covered in water, because this is how it's going to finish at the very end of this lab. Okay, I'm going to take it out, and I'm going to grab a paper towel and I'm going to dry it off. Okay, so it's being dried off right now. Then I can find the mass of it. So I'm going to actually put it on the scale, and I can find the mass of my lighter.
Then you're going to fill the 100 ml graduated cylinder completely full with tap water, and you're going to cover it with your hand and then submerge it in the large beaker. Make sure there's no trapped air bubbles in the graduated cylinder.
Now I need to fill my graduated cylinder with water. Okay. So notice the graduated cylinder is completely filled with water all the way to the top because I don't want to have any sort of air bubble. Okay? So this is the hardest part of the lab, and this is where you're going to get a little bit wet, and you'll be okay. Okay? So you're going to take your hand and you're going to cover the graduated cylinder. Okay? You're going to invert the graduated cylinder. Okay? Notice I don't have any air bubbles. If you look at that, I was able to avoid that. This is the messy part. Okay? So I would recommend having a partner actually tip the large beaker. Okay? And notice I'm using a 2,000 ml beaker. I don't have many 2,000 ml beakers, so you might have to use a 1,000 ml beaker. You'll be okay. And you're actually going to just invert it in there. Now notice I didn't do a great job here. I've got a little bit of air bubbles there. So if that happens to you in the lab, take this out, redo it again until you get almost none, if not no air bubbles. All right? So the main point is when you're inverting, put your hand over the graduated cylinder, flip it, and yeah, you're going to splash some water over the place, but that's totally fine. That's what happens in a lab.
Then you're going to hold the lighter under the water, making sure that the gas opening is beneath the mouth of the cylinder. You're going to lift the mouth of the cylinder slightly while keeping it underwater at all times. While holding the cylinder vertically, you're going to press a lever of the lighter, ensuring that all the gas bubbles enter the cylinder. You're going to displace about 60 ml of water from the graduated cylinder before you measure the volume displaced. Make sure to move the graduated cylinder so that the level of water inside it is at the same level as the water in the trough or the beaker. This ensures that the pressure of gas inside the cylinder will be the same as the atmospheric pressure that you will record.
Now I'm going to collect the gas. So I'm going to take the lighter, okay? And I'm not going to actually have the lighter start because I'm not creating a flame. This is what actually creates the flame, but the red button is what releases the gas, the butane. So I'm going to stick the lighter underneath the graduated cylinder, and I'm going to release air. And you can see it being released, that gas being released as bubbles. Okay, so you're going to release it until you have collected at least 60 mils of water. Okay, so this is going to go until you hit about 60 right here. Okay, now that I have 60 mils of my gas in there, notice the level of the water here is not equal to the level of the water here. And the reason why I want the level of the waters to be the same is when the levels of the water are the same, that means that the atmospheric pressure that is being experienced by the gas in the graduated cylinder is going to be equal to the atmospheric pressure out here. And the atmospheric pressure out here is what we're actually able to measure. So once I actually have noticed that the volume changes slightly when I move it up and down just a little bit, okay? So once I have the levels of the water lined up, then I can measure the exact volume of gas of butane that is in here. So right now this is almost exactly 60 mils. Okay? It doesn't have to be exactly 60 mils, that's fine, but somewhere around 60. Okay?
Then you're going to remove the lighter and shake off any excess water. You're going to dry it thoroughly in exactly the same manner you did in step 2, actually in step 1. Then you're going to reweigh the lighter and record this mass in the data table.
So I now have my lighter. It's going to be dried off. Okay? I'm going to weigh it again in order to find its mass. Then you need to determine how you would figure out the mass of the gas based on the initial mass of the lighter before I even started this lab and the final mass of the lighter.
Then you're going to remove the graduated cylinder from the water, walk outside the classroom, and release the butane gas outside.
Then, in order to dispose of this gas, because this is butane and I don't want my room smelling, what you're going to do is you're going to release the rest of the water. You're going to cover it with your hand, and you will take it outside, and then you can turn it right side up.
Then you're going to measure the temperature of water in the trough/the beaker and record this in the data table as the temperature of water / the temperature of the butane gas, and use this information to determine the vapor pressure of water. Finally, you're going to obtain the atmospheric pressure of the room, and you're going to record that in your data table.